So yeah, that video kind of talks about the power of monopoly type of situations. Something that economists are very concerned with is anytime we have too much power going to one place. Remember, Adam Smith's the one that brought up the benefits of competition. It's good to have people competing for things, and that's what gives us those nice results that we saw in perfect competition of some efficiency gains. And so we're kind of going to the other end of the spectrum now and seeing the losses that can occur to society when power goes too much to one place. So our definition of a monopoly, what were the three characteristics we wrapped up last time? One seller, homogeneous product because they're the only show in town, and barriers to entry. Something's keeping people from getting into that market. And so as we start to study this, of course this is focused on the firm, but we see potential abuses of too much power in a lot of different forms where there's a lack of competition. One thing that economists study is education, public education. The government has K through 12 education monopolized. You didn't really think about it that way, right? So they kind of have a monopoly on public education, and so what are the results with that? How's that working out for us with the monopoly? Is there a way to get, some competitive juices flowing in education? Healthcare, health insurance. There's other areas that are kind of bigger. But we're not going to tackle those right now, but those are some fun topics as we start to think about monopoly. I just wanted to expose the concept of monopoly power a little broader than just one particular firm dominating the market. But that is indeed what our topic is today. So the first thing we want to look at is how does this change the game for us? I just want to kind of quickly bring the graphic into your attention of perfect competition. Remember, we had Farmer Joe over here, the representative firm. They were producing some little Q. And let's just draw a demand curve now over here, not a supply curve. So don't draw full home base, just draw a demand curve. The story we told with perfect competition, we've got a drop of water in the bucket, right? We've got a large number of sellers that are selling this product, and so they are a price taker. They're kind of powerless. Whatever the market tells them they're going to get. Well, now the firm is a monopoly and is no longer a price taker, but a price maker. They're going to be able to set the price. So they have market power because the demand curve that the firm faces is not this one like we saw over here, it's this one. They face the entire market, right? So they have a downward sloping demand curve. So that's one of the key features that first comes out, is that the monopoly has what we call market power due to barriers to entry, and faces, put that in quotes, faces the market demand curve. And that makes them a price maker rather than a price taker. They are going to have the ability to set price. The ability to set the price that they're going to sell their products for. All right, so let's run with that for a moment. Using this demand curve, I want to think about marginal revenue. In the price taker situation, again, perfect competition, what did we learn about marginal revenue? The revenue generated by an extra unit produced was equal to, it's a good one to have right off the top of your tongue, right off the top of your lips, right off the top of your head. The marginal revenue, the revenue generated by an extra unit was equal to the marginal cost to maximize profits. I agree with you there. What else was it equal to? That's in the profit maximizing condition.
Equal to the cost of that at the last unit.
Yeah, so how much revenue, if this was the corn market, let's go back to the corn market, and the market price of corn is $6. What is the revenue generated by an extra bushel of corn equal to? $6. The price, right? So the demand curve is the marginal revenue curve. Marginal revenue was equal to the market price. So those two things were one and the same. Price equals marginal revenue in perfect competition. Now, back to the monopoly, different story. Let's say that this intercept up here is $8. And now I'm going to just go 7, 6, and maybe we'll just stop at 5. And let's say that a $7 price, again, the law of demand, using the demand curve, is telling us that the company can sell 1 unit. And if the price is $6, the company can sell 2 units. If the price is $5, the company can sell 3 units. So, what is the marginal revenue associated with the first unit? What is the revenue generated by the first unit? $7, right? So $7. I've got a first unit here is $7. That means my marginal revenue is $7. What's the marginal revenue of the second unit? $6.
It's the change.
So, what is the revenue generated by producing a second unit? How much am I going to sell it for? 6. Is that the revenue generated by it?
Revenues before we take out costs, so yes.
You're asking marginal revenue or just revenue?
Marginal revenue, yeah.
It must be adults.
We're selling it for 6. And
So,
one of them.
did we do a formula for marginal revenue?
I don't think so.
We might not have because it was similar. I honestly can't remember. So,
I was looking for
It'll be
today.
but we did verbally, right? The revenue generated by an additional unit, exactly what I've been asking for. So, what's the revenue generated by an extra unit? What was marginal cost formula? That one I know.
Yeah.
Marginal cost formula now. What did that look like?
Number produced.
Number produced, it had something related to the quantity produced. The marginal cost, the cost of an additional unit. What's that formula? I need some equation goggles on.
Marginal cost is equal to average total cost divided by, or change in average total cost.
Good, yeah, that's not an A.
Yeah.
Okay. So it was the triangle,
Yeah.
right? The change in total cost divided by the change in quantity. Now notice if I would have did this, total cost divided by quantity, what's that equal to?
Average total.
Average total cost, right? So you got to keep those straight. That little delta, that triangle there is important. So it's how total cost is changing when I change quantity. So what do you figure marginal revenue is? Change in total revenue divided by change in quantity. Yep, I'm not pulling any punches on this one. Change in total revenue over the change in quantity. What is the total revenue generated by producing 1 unit in our example? What is the total revenue generated by producing 1 single unit? $7. Price times quantity equals 7 times 1 equals $7. I'm really showing my work here, right? That's like almost absurd that I'm writing all that out. What is the total revenue generated by producing 2 units?
$13.
12. Aha. Right? In order to sell 2 units, I had to lower my price to $6. So that's the catch. So total revenue with 2 units is equal to $6 times 2 equals 12, making the revenue generated by the second unit technically equal to 5. You got it. So the revenue generated by the second unit is not the price I'm selling it for. By the way, I'm still selling it for 6, of course, but I'm only generating $5 worth of revenue. Now, can anybody articulate why that's the case? We kind of worked through it. Hopefully you're seeing it. I just want to see one more thing. Why am I only earning $5 worth of revenue even though I'm selling it for 6?
Because you lost $1 on the first unit.
Good. You lost that dollar on the first unit, right? That's what's driving this result. How about the marginal revenue of the third unit, the revenue generated by the third unit? Gosh, I'd love to see the smoke coming out of your ears. It's like a little squeaky wheel. There's a little rat running around in a cage in there.
It's
3! How'd you get that?
That was my first guess.
15.
I'm not sure that's right.
15 minus 12.
15 minus 12. So in order to sell 3 units, I have to obey the law of demand, right?
Right.
So in order to sell 3 units, I have to drop my price to 5, which gives me TR3 at the P3. I guess I'm doing this kind of like this. We get $5 times 3 equals 15. The revenue generated by the third unit is $3. The revenue generated by the second unit was $5. So we've got that same thing going on. So for 3 units, the revenue generated by the third unit is 3. And that then, if you connect these 3 dots, ends up being the relationship between demand and marginal revenue for the monopolist who can only charge a single price. So I want you to add this somewhere on your notes here. We're kind of assuming what's called a single price monopoly. In other words, they can only sell their product for a single price.
Instead of like selling to a higher price to different markets.
That's right. Instead of different prices to different people, which is called price discrimination, which is totally legal, as long as you don't do it with the protected classes in the United States. You guys ever been on an airplane? How many people have been on an airplane? Did you guys all pay the same price for those seats to go to the same destination at the same time to the same place? No, because the airlines price discriminate. They charge different prices to different people. Totally legal. It's done all the time, all over the United States. We'll get to that topic later. But here what we're analyzing is a single price monopoly where in order to sell more units, they have to lower the price. Not only for the extra unit, but for all the units. Single price monopoly. Okay, good. So we got this formula, we got this formula. So this is, again, kind of the marginal revenue. So if we were doing a little schedule goggles here, notice we kind of do something like this here. Marginal total revenue was 7, 12, 15. Marginal revenue is going 5, 3, and it would go down the line from there. All right. So questions so far? Can marginal revenue be negative? Is it possible that the revenue generated by an extra unit is less than 0? Can marginal revenue be negative? I.e., can that marginal revenue be less than 0?
based on the law of diminishing returns, our cost is going to go up over time. So if
Not dealing with cost though.
all right.
Costs are off limits right now. We'll come back to that shortly. So, can the revenue generated by an extra unit be negative? Yes. Yes is the right answer. Why is a much more difficult question.
I was about to say.
What might help, believe it or not, is the thing that I asked you to memorize. We're going to actually tie this back to elasticities. I thought we were done with elasticities. No, we're not done with elasticities. So remember this graph that had two things stacked up on top of each other? The top part was the demand curve. And if we eyeball the midpoint between where the demand curve intersects the horizontal axis, that would be about here. What was the elasticity of demand right there? 1. That was unitary elastic. And anybody remember this section of the demand curve? All these numbers were elastic. Good. So this was the elastic range of the demand curve, which means it's greater than 1. So this is elastic range. And then these were less than 1.
It's inelastic.
And inelastic. Now, how did that connect down to total revenue, which equals price times quantity, which is exactly what we were just doing, with totals anyway? What did this creature look like down here? Anybody remember? A hill, right? It was kind of a humpy thing. So, how did this point correlate with the humpy thing? It was the peak. That's right. It was the peak. And so here, price is 0, so revenues are 0. There's your hump, kind of goes like this. And that is a total revenue function. As quantities are increasing, revenues go up for a while, but then eventually you're out of luck and revenues are going to fall. So the revenue function is nonlinear and looks like that. All right, so we've now learned the marginal revenue bit. And what I didn't tell you is that the marginal revenue curve is twice as steep as the demand curve. So the marginal revenue curve, you can draw this on the old graph or this one, it doesn't matter. But I want you to know marginal revenue is twice the slope, twice as steep. 2 times steeper. So that was the connection of when you draw it. And then the little trick that we can use then to make this twice the slope, it meets that point right at that midpoint. And that's your marginal revenue. Now back to my question where we got into all this mess. Can marginal revenue be negative? Yes, because that's exactly what's going on here. As I add more and more units here, my revenues start to fall, which means the incremental amount of money that it's adding to my revenue is negative. It's pulling away from my mountain of cash. You can literally think of this as kind of building up a mountain of cash, and now my cash pile is starting to fall because I'm taking away money by going too far into this. So the full marginal revenue function extends into that space below the horizontal axis, and that's the real marginal revenue curve. So it can be negative. So the answer to the question is yes. Marginal revenue can be negative. Yes, because in the inelastic range of the demand curve, in the inelastic range of demand, total revenue falls. with decreases in price and increases in quantity. That means those incremental units are less than 0. Okay, so this is really the only thing we added to this picture from before. Remember, this was kind of a helpful tool on what you should do with pricing as it relates to revenues. If you're thinking it's a good idea to cut your price, you might be cutting your throat if demand is inelastic. In fact, you should do just the opposite thing if you want revenues to go up, because a decrease in price from point C to point D corresponds with points C prime and D prime on the revenue function, and total revenues are going to fall. All right, so any last questions there? All right, now we got to start talking costs. Oops, sorry. Now we're going to start talking cost. Let's see. Right there. So draw this monopoly graph. The way we've got it. Now you've got this extra trick here on how you draw the marginal revenue curve. Take that bisection point and you can draw a nice little pretty graph. Go ahead and dip it negative if you want. Looks something like that. The one thing a monopolist can't do is get rid of the law of diminishing marginal product. That's just there. It's kind of one of those laws of economics. And so that causes them to face a marginal cost curve similar to Farmer Ted. And now, the moment of truth. Jason, how does a firm maximize profits? Alex, how does a firm maximize profits? The thing. Trace, how does a firm maximize profits?
Quantity where the revenue is generated by the last unit produced, which is equal to the cost of the last unit.
Awesome. Alex, how does a firm maximize profits? Trace, how does a firm maximize profits?
Quantity where the revenue generated by the last unit produced is equal to the cost of the last unit.
Excellent. Alex, how does a firm maximize profits?
say it so fast.
Trace, how does a firm maximize profits?
The quantity where the revenue generated by the last unit produced is equal to the cost of the last unit.
Alex, how does a firm maximize profits?
Quantity where the revenue generated by the last year produced is just equal to the cost of the last year.
Excellent. Jason, how does a firm maximize profits?
What is the quantity where the revenue generated by the last year?
Awesome. All right. So, where is the most profitable production point for our monopolist? How can we put that into words here? Is this a good quantity to produce?
No,
Why?
you could be making more money.
Let's think about that for a sec. So is this a good quantity to produce?
Isn't it where the marginal cost curve and marginal revenue curve intersect?
Marginal cost equal marginal revenues over here. So let's look at the logic of this a little bit different. Let's say this is 100 units. What is the revenue generated by the 100th unit? I go up to the marginal revenue curve, I hang a left. That unit's bringing me in this many dollars. What did it cost me? That unit cost me this many dollars. Should I do that unit? Yes. Let's try the 101st. This unit brings in revenue of this amount of money. This unit costs me this amount of money. Should I produce that unit? Yes. Keep producing until the revenue generated by the last unit produced is equal to the cost of the last unit. That's where these two meet. That's exactly what we learned in the last chapter. It's the same thing for the monopolist. The quantity for the monopolist is right there. Now, what is the price for the monopolist? On your graph, talk to me about the price. I want you to show me graphically on your papers as I walk around what price you think the monopolist should charge. So you got 10 seconds. I want to see everybody with their,
I guess, create numbers.
point to their pencil or pen on their paper. You got 5 more seconds. 3, 2, 1. There.
Yeah.
There.
If you go up to, sorry, so the demand will go down.
Close.
Oh, there.
There. Where's your pencil?
I was on the.
Put it on a spot. I will help you. There. Down. Up. Up. There. Right there. All right, so what we want to do is charge the highest price people are willing and able to pay for that quantity, which we go up to there and hang a left, and that price right there tells us the highest price people are willing and able to pay for that quantity. So let's just say, using these numbers that I'm just kind of making up here, let's say this is 146 units. What should we charge? We should charge the highest price people are willing and able to pay. What information gives us that? The demand curve does. The demand curve gives us the relationship between prices and quantities. So let's charge the highest price people are willing and able to pay. Hang a left, read off that number. That is the price that the monopolist should charge. So the monopolist is going to produce a quantity of 146. They're going to charge a price of whatever that number is. Let's say that number is $14. How much money is the monopolist making? I'll just tell you right now, it's kind of a trick question. What's that? Wait, I think I heard the right answer. We don't know! That's right. There's not enough information to calculate profits. What information is missing that would be helpful to calculate the profit? Total cost. And what, we don't usually graph total cost here. What do we usually graph? Average total cost, because then we can backdoor it with that equation of profits equal total revenue minus total cost, which could be rewritten as price times quantity minus average total cost times quantity, which is then simply restated as the difference between the price and the average total cost times the quantity we produce. But we don't have that information. All right, so let's add that. Now, there was the one rule about marginal cost and average total cost. What was that? Little rule, chapter 11, between marginal cost and average total cost. Intersects at the bottom of the barrel, right? The bottom of the bowl. So it doesn't really matter too much where you put this in. I'm just going to have it cut through here. Put the big fat dot and then have it come up. That's the most important thing we got to obey, is that rule. Now we can fill in the rest of this equation. If this was $14 using the numbers I made up, how do we find the average total cost of producing 146 units? We go up to the average total cost curve, hang a left, and read off that number. Making up some numbers, let's say it's 10 bucks. So on average, we're making $4 per unit times the 146 units would give us our total profit. Profit goes out to the market. Profits act like a signal. What is the signal? Enter, 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 enter. Other firms come in and try to enter, but what do they find?
We're bullies.
There's a big wall, the Wall of China, the Great Wall, the Berlin Wall. There's some sort of barrier to entering. They can't get in there, right? So the barriers to entry keep those profits alive, because the story we told when there's competition is that price will fall when there's competition. So when there's more firms entering the market, the price will adjust down. That's not going to happen here because of the barriers to entry. So this area here, now watch this part. Total revenue is price times quantity. So this big rectangle is really total revenue. The area of that rectangle, price times quantity, is total revenue. Total cost, we learned down here, is the average total cost of 10 times 146, which would be, I can do that one in my head here, $1,460, is this rectangle. If I take this rectangle minus this rectangle, I get that rectangle. And that is the economic profit associated with the monopoly. And again, you can kind of see the area is a height of $4 and a base of 146. So that gives us that area. All right, let me pause there for a sec. All these pieces coming together for you? Questions? What's your question? Go ahead, let me know.
It's economic profit or it's total?
Its economic profit is down here, yes, because the revenue, we would have had to do it up here, was $14 times 146. So let's just make this complete. Somebody with a calculator, I just made these numbers up. 4 times 146?
584.
584. So $584 is the amount of profit. Okay, so some key points here. Some key conclusions to monopoly. Number one, we expect economic profit greater than 0 in the short run and the long run, because there's barriers to entry. So that's an important part of this. And that's what we see here. We can capture the inefficiency by thinking about the monopolist quantity versus what we might find in competition. So there is no allocative efficiency. The monopolist is not allocatively efficient. We wrote that out last time in the notes, so I'm just going to put AE. Allocatively efficient. Not allocatively efficient. What did we need for allocative efficiency?
Marginal cost and marginal revenue.
Marginal cost was one part of it. That needed to be equal to marginal benefit. That's right, good. So there was a distinction there between benefit. Now, in the case of perfect competition, the marginal benefit equaled the marginal revenue. What is the marginal benefit curve up here? Demand curve, right? That was back from chapter 2 or 3 whenever we covered that. So the demand curve is the marginal benefit curve, the benefit derived from an additional unit. It is not equal to the revenue generated from an additional unit. And so the monopolist tends to underproduce what would be allocatively efficient. Allocative efficiency happens here, where marginal benefit and marginal cost intersect. That's right here. And that does not need to intersect this. So I'm going to put it a little off to the right here. But this is QAE. So not allocatively efficient because marginal benefit does not equal marginal cost. The quantity that the monopolist produces is less than what's allocatively efficient. This is what we call an underproduction relative to what would be efficient. There's an underproduction. by cutting back on quantity, by using their power to kind of restrict quantity, what happens to price? It goes up. So that's the other part of monopoly that kind of has nice intuitive feeling to it, right? That if somebody's in control of the situation, well, they can charge whatever they want, like our airplane example, right? Charge for the seatbelt. Once they got you on there, then you've got no place else to go. So we're going to lead to a price that's higher than what we'd see in competition as well. So we'd say maybe some underproduction and overpricing compared to competition. Compared to competition. All right, that gives us something to look at, kind of the waste associated with the monopoly. And so, let's see, I'm going to do blue, I guess. The monopolist is producing 146 units. The efficient quantity for society might be out here at 169. Just making up numbers again. So what's wasted? What's the real waste for society? Well, there is benefit to the 147th unit. Somebody's getting more benefit than what it actually costs society. So in theory, we should do that. That's why it's inefficient. Same thing with the 148th unit, the 149th, the 150th. We can tell that story all the way out to here. That's why we called that quantity allocatively efficient, because the benefit of the last unit was equal to the cost of the last unit. And so over this area, this unit, this unit, this unit, these are kind of like waste to society. And so this triangular region can be thought of as the deadweight loss for a monopoly. The deadweight loss for monopoly. Similar to the deadweight loss we saw with a tax, right? Remember we had that triangular region? Kind of a similar thing going on where because the quantity's not at this point, we have deadweight loss, some waste. All right, questions on that at all? Another conclusion. We are not productively efficient. So last time we looked at perfect competition and I brought up these notions of efficiency. What did it mean to be productively efficient? What do you got in your notes for that? What's going on? What's that?
On the PPF?
On the PPF was one way of looking at it. How did we tie that back to this picture?
The minimum of the average.
The minimum of the average total cost. So conceptually, you want to think that, okay, if society is cranking out this quantity or this quantity or this quantity or this quantity, is that the most cost-efficient quantity, or can there be some changes made? And so here we've got the monopolist producing 146 units, but you can see that that's not on the mark for what would be productively efficient, which is this point, where it's at the minimum. So this would be the productively efficient point. So we're not productively efficient because we're not at the minimum of the average total cost. So, how's monopoly doing for society? Is this a good thing to try to have in society? No. That's why they're illegal in society, right? So there's antitrust laws that keep firms from essentially gravitating into a monopoly. In some cases, it's a natural thing to do. Who was on the hot seat here in the last, the last year for sure, if it wasn't the last 6 months, in cell phones that were trying to merge? T-Mobile and AT&T. So T-Mobile and AT&T, had there been a completely free market, if you will, without any government intervention, they wanted to merge together. And the government didn't let them merge together because in their determination, the cell phone market would get too concentrated. You guys observe pretty easily the benefits of having multiple cell phone companies, don't you? Right? They're always trying to put out these ads to try to lure you to their side. That's competition. We want to keep that. And so that type of thing goes away when we let too much power go to one particular organization, entity, firm, whatever it is. Okay. Any last comments there? So, how do we get things a little bit more complicated? Since we brought up price discrimination, let's look at that issue. So, price discrimination is the ability of the firm to charge different prices to different people for the same good. So, price discrimination. Price discrimination is charging different prices to different consumers for the same good. So, for example, we had the airlines. Give me some other examples.
I know that this might be a really left field example, but in like construction, like home improvement sort of jobs, that they'll often do their estimate based on how nice the house is.
Okay. Yeah, there's certainly some of that going on. The thing I hesitate a little bit, so I'm going to go ahead and put that down, but I just want to put it down with construction bids, is the estimate part. So part of the reason that they could be off is because they're a poor estimator, right? And so they put too much fluff in the number. But possibly, if the person doesn't shop around, and they've got a nice home and it looks like they've got a lot of money to spend, then we can start, charging a little bit more. Whereas if you go into the other edition and they're in the kind of the starter home, and as you're going through the construction process, the husband and wife are telling you, oh, well, we got one on the way and our other 3-year-old's in the back, and so things are tough, but we think we might be able to, to get by and do this addition. All of a sudden, maybe they'll be thinking a little differently on how much they're going to charge for some things compared to others. So good, a good example. Sawyer.
Would like people who don't have to pay taxes, like government people, would that be one of them? Or no?
No, because with the taxes, we're kind of out of the marketplace. So I want to stick to market examples of prices being traded and our goods being exchanged between seller and buyer.
Like sporting venues?
Okay? How?
Like people who pay like closer seats than others, are they?
Okay, now we got to be careful. Closer seats might be better than the cheap seats, right? So you're good with that. We got to be careful that the good is close enough. So how about if we had seats in the same row? So that we're kind of taking away that. Do we have that going on in sporting events?
Sometimes, like depending on like the time frame that you purchase them. Like
Okay.
if you purchase them far enough in advance, they're cheaper.
That's right, and that's a different form of price discrimination, but advanced ordering would be probably a possibility. Advanced orders. So we're going to kind of sock it to the people who didn't plan ahead. We want to get people who might not be able to afford to go to the event, we give them some sort of a discount. But others, maybe not. So advanced orders. Actually, I just saw this. My son's going to Worlds of Fun for a school trip. And apparently, if you order your tickets to Worlds of Fun 3 days in advance, the tickets are $3 cheaper. So that would be an example of a type of price discrimination. Rachel?
When Decker went to New York City,
Yeah?
the street vendors would charge different price for a hot dog for like a man or a woman.
That's interesting. Okay.
Yeah, street vendor. 'Cause I remember, like,
Street, I've never heard anybody comment that, but street vendors in New York. So, and maybe the way you were dressed or gender,
Yeah.
whether you're female or not, maybe how you're dressed, that sort of thing. Okay, interesting.
It was funny.
Other examples. Yes, just concerts. Good. So that'd be kind of similar to the sporting events, right? So good. Yeah, concerts might be another thing. Yeah.
Could scholarships be one?
Scholarships are definitely one. So, education. Scholarships. Alright, so if you're on an athletic scholarship, you might not be getting the same thing as somebody else. Maybe you're equally skilled, maybe you're not. It could get muddy if we, talk about that type of thing. But there's academic scholarships that works the same way. So that is a form of price discrimination that Ottawa University engages in. I can see it in the paper now. OU practices price discrimination. How about that for a headline? According to Dr. McCullough. Don't do that, please, because Dr. Eichner would probably
Lose your job so
All right.
fast.
Other examples. But it's true.
Good thing you know
In the purest sense of the word, it's totally legal. Everybody's doing it, so why don't you do it? It's a profitable thing to do. Back to that example where we had the demand curve, you can start to see the advantage to doing it right away. So let me just quickly draw this $8, the exact same thing we had before, 1 unit, 2 unit, 3 unit. If I can charge $7 for the first unit, $6 for the second unit, and $5 for the third unit, I can engage in what's called perfect price discrimination. For every unit that I'm producing, I'm getting the most I can from every individual. And now we've got what you were saying before of $13. Now I've got $7 from the first one, $6 from the second, and $5 from the third. So I'm getting $18 worth of revenue by engaging in price discrimination. When it's perfect price discrimination, the demand curve and the marginal revenue curve now lie on top of each other. The revenue generated by each additional unit is equal to the price that you're charging. That's price discrimination. We'll pick up there on Friday.